midpoint. And again, you've got three medians in a triangle, AE, BF, CD. Those are all medians. They are concurrent, which means that they all intersect at the same point. And when we have concurrency of medians, we call that point the centroid. So this one right here, P, sometimes it's labeled other things, obviously. This is called the centroid. It's the point where all the medians meet. And then you've got a theorem in that box there. From the vertex to the centroid, it is 2/3 of the way. So this top part here, in our case, BP, that's 2/3 of the way to the midpoint. So then this section right here, PF, that would be 1/3 of the way. And that is the case for all the medians in the triangle. Sweet. We're doing two examples. First one. In triangle FGH, M is a centroid. You're given that. And we know that GM equals 6. Find ML and GL. So we just talked about how the centroid, M is a centroid, and it is 2/3 of the way from G. So this is 2/3, 6. Hey, some of us can probably do this in our head. So then, how long is GL? 9. This part is 3, because 2/3, 6 is 2/3 of 9. If you can do it in your head, that's perfectly fine. I am going to ask you to write this out just for now, because not all of them are going to turn out to be that easy. And so you might actually have to do some algebra for some of them to get your answer. So I'm going to write it out. I would ask that you do the same. 6 is 2/3 of GL. And so in order to find GL, you want to solve. You can multiply by 3/2, which is the reciprocal, or you can do it in 2 steps. Start by undoing the division by multiplying by 3 on both sides. So then you would get 18 equals 2 GL. Divide by 2, and you get the same thing you guys just told me, that GL is equal to 9. And so then we know the remainder, ML, would be equal to 3. That's really it. Okay. Don't flip it over yet, because there's one more thing I need to point out on this page. And we'll talk about something you already know, some prior knowledge that you have, and how to connect it to this. So the centroid comes from the medians meeting, and the medians come from the vertex of the triangle to the midpoint. And so the centroid is where those all meet. Let's backtrack and let's think about, we had a midpoint. The midpoint between the two. This is your formula for that. The x1 plus x2 divided by 2, y1 plus y2 divided by 2. That's from last semester. What are you actually doing here? Because you don't need a formula. Sam, what are we actually doing? It's averaging. Yeah, you're averaging between the x values, you're averaging between the y values. And so you can do the same exact thing to find the centroid. You average between the 3 points from the vertices to find, what you're basically doing is finding the midpoint from all 3 vertices. And so we can average them. You can find 2/3 away. Find 2/3 away from each vertex, but it's pretty obnoxious. You can just find the average between all 3, and it works just the same. So that's what we're going to do. I'm going to write out like the formula for it, but just keep in mind all we're doing is averaging between the 3 vertices, just like you did with the midpoint. So to find the centroid, hello. You add up all three x values, and there's 3 of them, so you divide by 3 to average. You add up all 3 y values. You divide by 3 to find the average. So just plug in your x values now, plug in your y values, average them. You might not even have to write this step out necessarily. You could do it in your head. I'll write it out. X values are 1 plus 4 plus 7. Divide that by 3. Y values are 2, 6, and 4. Divide that by 3 to get your centroid, which is basically the midpoint between all 3 vertices. That would give me 12 divided by 3 and 12 divided by 3. So where is my centroid, guys? Where is it? 4, 4. That's it. You have a question on the front? I don't remember what it is. I'm sorry these aren't hole punched. They didn't hole punch them at the copy center, and maybe I forgot to tell them to. What is true about the medians of a triangle? Can you answer that in complete sentences, please?